Hello and welcome, or welcome back, whatever the case may be. It is time once again to try to fix something. And today on the workbench, I'm looking at another PS5 Blu-ray edition. And I do not recall what the problems are with this console, but I do think roaches are involved. Just looking at the little particles I see just inside there on those white plastic parts. So I do think some roaches are involved, whatever this thing's problems are. We have power though. Oh, but we don't. Okay. We have power. Well, I thought this was going to be a dead power supply due to roaches. Not so fast. So we get an occasional beep, no lights, and then the beeping stopped. Okay, occasional beep, but no lights. Eject beeps pretty much every time. So, okay, this could be an interesting one, but it's not a dead power supply. Well, let me get on into it. Let's just see how nasty this thing is inside. Well, as far as how nasty it's going to be inside, well, yeah. But, nope, not sealed. Not sealed at all. Somebody's been into this thing. Did they put back all the screws? Hopefully. Well, this is pretty bad. Yeah. That fly paper works wonders though, doesn't it? Yeah, this one's going to need a lot of cleanup. This has got to be the worst PS5 I've seen. And here we are down to the circuit board. And I've been using the air compressor to blow away the bulk of the mess as I disassemble. But yeah, there's going to be a lot of cleanup involved in this one. Yep, everything's got to come out and you get a good scrubbing. Alright, here we are inside, ready to take a look at this circuit board for our PS5. And of course, most of the plastic parts and chassis parts for that, for this console are in the bathtub full of hot soapy water soaking. I'll deal with that part later. Let's see if we can make this board come back to life. And I'm just kind of curious at this point what kind of current it's drawing off of a 12-volt supply. So I've got that connected, hopefully correctly. Looks like it. I don't think the south bridge is totally dead because it tries to turn on. You hit the button, it responds, it beeps. Of course, you don't get any lights. So anyway, I'm just kind of curious if our south bridge is alive and well. Let's just see what kind of current draw we get when we enable this. 300 milliamps and come back down. No, we're going to hang. Okay. Something's not right, obviously. She's hanging at 300 milliamps, so it never finishes what I call the initialization. I don't know what the official name of it is, but that's what I call it. Try that again. And the current is kind of high to begin with, 50 milliamps. Normal is like 14 or 15. That's a bit different. I don't think I've ever seen that before. So we're hanging at 350 milliamps, right? So that's a starting point. We should probably look around the board, see if we can find anything shorted, or if we have our 5 volts and 3.3 volt supplies. Let me get you in a holder, and we'll start that process. All right, maybe we'll just see, do we have our 5 volts? I would imagine we do because it's doing some stuff, so it's got to have 5 volts, which I believe is right here. Make sure everything is in the picture there. Let's just confirm it though. Of course, 5.1 volts, that looks good. I guess I can just leave the power on. Oh, this is an EDM10 board, by the way. So I do have one of these to compare to. 5 volts. Where's that 3.3? Is it on the opposite side of the board? Let me see what we have. Let me look at the other side of the board. This could be hard to do without knocking my leads loose. And which I did. All right. Now I was thinking that like this is the 5-volt area is what I was thinking. No. I guess I should pull up a diagram, but I'm too stubborn to do it. 5 volts there. Is this 3.3? Not at the moment, it's not. All right, let me turn this 12 volts off and back on and see if it's 3.3 momentarily. No, it's not. That's a bit odd. I really think this is the 3.3 generator, so it takes in 5 volts here and outputs 3.3, but I could be wrong. What kind of resistance do we have at that point? Ooh, 0.7. That's not exactly. Let's zero this out. Null that out. Let's just see just how low this is. Yeah, about 7/10 of an ohm. 6/10, 5. It's wandering around. Let's just say 6/10, 7/10 of an ohm short to ground on that rail, which I need to look it up and see. I think that's 3.3. But that's not right. So we have a short on this supply, which I need to confirm. Let me check and see what it is so I can y'all know what to say. All right, how about this? I have swapped to my spare tester board, whatever you want to call it. Let's see what this point is right here on this board if I enable 3.3. So it is a 3.3 volt rail. Takes in 5 volts over here, outputs 3.3. So we've got a short on the 3.3 that we have to find. Okay, I thought it was 3.3. I guess my memory is not totally gone. 3.3. So here is this board. Maybe time to crank up the microscope and look around. I don't suppose it's going to be things like real obvious that we can just see. That'd be too easy. Probably going to have to inject some voltage because it's probably not right here. That'd be way too easy. 3.3 is used in a lot of places on this board. It's used, I believe, here in the Wi-Fi module. Speaking of which, what if we check around that Wi-Fi module? Several of these bypass caps here. That may be ground. Nope, and it's definitely a short there. But I mean, I don't know that it's there. I just mean it's on the 3 volt. Do you know what? There's a lot of corrosion right here on the back side of this Wi-Fi module. There's a lot of corrosion there from roaches. Show you. There's the Wi-Fi module, Wi-Fi and Bluetooth, and that's a possibility. Get my cord situated here. Let's take a look at that area under the microscope if we could. Because some of these capacitors look pretty rough. Yeah. Make sure that's in focus. Take a look at some of those. I mean, several of those are candidates for being shorted. Let's just pick this right here. That one in the middle of your screen. Let me see, what do I measure? I'll null out my leads again. If I go, of course, this side is ground, and that is, of course, reading a fraction of an ohm. And this side, yeah, also a fraction of an ohm. So that's a possibility. Of course, I think I want to say there's 2 rails going into this Wi-Fi module. Oh, look at that capacitor right there. I didn't see that earlier. Look at that nice little crack in that thing. Yep. So what we measure there. If I can get contact on it. There's not much to get contact on it anymore. It's gone. Yeah, that reads 0.08 ohms right there. 0.08. I think I'm just going to let's just pop this thing off of there. Make an executive decision here. What if we just pop this thing off here? Didn't take much. Not much left of that end cap, was there? Now what do we have? Right here. There you go. 1.5 k ohms. 1.5 k ohms. Well, that was just too easy. I need to check, see what the value, because several of these capacitors need to be changed out. Like that one there. Make sure you can see it. That one, those there, they need to be changed. Those, I don't trust them. Because they could fail at any moment with the amount of corrosion they have on them. Where is that capacitor? I want to get a hold of that one. Just save that off to the side. Okay, let's just see what our current draw is now, shall we? Yeah. Let me get this reconnected, and I'll reposition the camera. Don't you love it when the capacitor just says, "Here I am, right here. It's me. I did it. I brought the whole system down." All right, let me get you a shot. All right, we are reconnected. Let me get zoomed back out. Polarity is proper. Let's just see what kind of current draw we get now. Yeah, that looks more like it, doesn't it? Then come back down to 14 milliamps. There you go, 13. That looks normal. I think this is a working board now. I do believe this is a working board. I need to figure out what the value of those caps are and go ahead and change several of them out. And let's see, we can also check. Let me flip this over without knocking my leads loose. Let's just confirm that we have our 3.3, shall we? I'm trying to set my meter up with one hand. There. And yeah, let me turn this on. And if we check right here now, 3.31. Love it. All right, let me see if I can figure out what those capacitors are, and see if I can find some replacements. It would be nice if I had some on hand, wouldn't it? All right, our capacitors are replaced. I think I replaced all but 4. If it had corrosion on it, I replaced it. So I think we're in pretty good shape here. These were all 10 microfarads, by the way. Every one of these were 10 microfarads. And I thought I would have some. I didn't have any of that size. I think it's an 0402. I'm not positive. It's an 0402 would definitely fit, though. And that's what I'm going to order going forward. But these came off a donor board over here, of course. That's where I pulled them from. And these were all 10s except for this one right over here was a 0.1 microfarad. So anyway, those are all replaced. Other than a lot of cleanup, we'll be ready to test this thing very soon. Let me get to cleaning up on these chassis parts, which may take me a while, but well, here we are back out of the garage. This PS5 is fully reassembled after a lot of cleanup, and I had to disassemble everything. Of course, everything had to be scrubbed. Of course, all the chassis parts, the PCB, everything. The power supply was working fine, but I did have to clean it out, and it was full of nastiness, as can be expected. So disassembled that, cleaned that out. Cleaned its case parts, cleaned its circuit board, put all that back together, cleaned the fan, all the usual stuff. And I have not even tested this thing yet. I have not tried to turn it on. I very overconfidently fully reassembled it. I mean, we found the shorted capacitor. That should be it, right? That should be the only problem. I replaced them. That should be it. Let's see what happens, shall we? No lights. I think I may have that ribbon cable plugged in wrong, though. Let's see what happens. Any video? Oh, come on. Yep, there we go. There's video. I think I've got to fix the ribbon cable. I wasn't sure how to turn it where it plugs into the circuit board here. I had a 50-50 shot, and I think I turned it the wrong way. And she's done her storage check, and I think she's going to come up. There we go. Let me fix this ribbon cable. It's bothering me. I need to see that white light. All right, well, I think the basic problem is if you mount the LEDs turned the wrong way, you don't see any light. Yep. There we are. That's better. Much, much better. I should probably edit all that out, but I probably won't. And there's our logo. We are working well. I'm going to put this thing through quite a few tests. Make sure it's not overheating or anything like that. But I think she's going to be good to go. Well, I hope you enjoyed that one. Thought it was somewhat interesting or educational, entertaining, whatever. If you did, please give me a thumbs up. And I will see you in the very next repair. So long for now.